Video 11.2, Day 2, Theoretical and Experimental Probability. Please write down the essential question. How do I find experimental and geometric probability? Geometric probability is a form of theoretical probability determined by a ratio of lengths, areas, or volumes, depending on what's asked in the problem. We talked about theoretical probability in Day 1. Here's example 1. Find the probability that a point chosen at random inside the large triangle, so let's highlight what the large triangle is. Inside the large triangle, there it is in the small triangle, which is right there. That's what we're trying to figure out. The probability that a point is inside the small triangle is the ratio, fraction, of the area of the small triangle to the large triangle. That's what we're doing here. It's telling us the area of an equilateral triangle, because that's what this is s squared root 3 over 4, where s is the side. So geometric probability, more often than not on your problems, you're going to always be taking the ratio of the area of the smaller shape divided by the area of the larger shape. Obviously, the denominator is going to be always larger than the numerator, because the maximum your probability can be is 1 or 100%. Here we go. Let's find our areas. So let's do the area of the small first. The sides are 4. So S is 4. So area of small triangle then is going to be s squared root 3 over 4, which is 16 root 3 over 4, which is going to be 4 root 3. There's the area of the small. Now let's find the area of the entire triangle. Those sides are 15. So that's going to be area of large triangle. So it's going to be 15 squared over 4. Well, 15 squared is 225. And there is our area of the large triangle. To find the probability that a point is inside the small triangle is also in the large triangle, that a point chosen at random inside, let's say that again, that a point chosen at random inside the large triangle is also in the small triangle. So our probability is going to be the area of the small divided by the area of the large. So I'm going to take the top times the reciprocal of the bottom. The root 3's cancel. 4 times 4 is 16 over 2, 25. And there is our probability. And that is geometric probability. You can estimate the probability of an event by using data or by an experiment. For example, if a doctor states that an operation has an 80% probability of success, 80% is an estimate of the probability based on similar case histories. Each repetition of an experiment is a trial. The sample space of an experiment is the set of all possible outcomes. The experimental probability of an event is the ratio fraction of the number of times that the event occurs. That's in the numerator, the top. That's the frequency, to the number of trials. And here is our formula for experimental probability. Experimental probability is often used to estimate theoretical probability and to make predictions. Example 2. The table shows the results of a spinner experiment. So this is an experiment, experimental probability. Find the experimental probability of spinning a number greater than 2. Numbers 3 and 4 are greater than 2. All right, so here, let's talk about what this table represents. When they did the experiment and they had a spinner that had 4 options, you could land on 1, 2, 3, or 4. They landed on 1 when they spun the dial 6 times, 2, 11 times, 3, 19 times, and 4, they landed on 4, 14 times. So the first thing we want to do is add those up. 6 plus 11 plus 19 plus 14, that is 50. We spun the dial on the spinner 50 times. So the probability of spinning a number greater than 2 we're going to be focusing on these. So our probability, the denominator is 50 because I spun the spinner 50. I spun the spinner 50 times. How many times did it land on 3 or 4? That would be 19 plus 14. 19 plus 14 is 33. And there is our probability. Example 3. The table shows the results of choosing one card from a deck of cards, recording the suit, and then replacing the card back in the deck. Find the experimental probability of choosing a diamond. All right, so here's how we interpret this. We have hearts, diamonds, clubs, and spades on cards. 5 different times when we did this experiment, we picked a card that has a heart on it. 9 times we picked a card that has a diamond on it. 7 times we picked a card that has a club on it. And 5 times we picked a card that has a spade on it. So the first thing I want to do is I want to add up the number of cards I picked in this experiment. So 5 plus 9 plus 7 plus 5 is 26. That's our denominator. They want to know the experimental probability of choosing a diamond. How many times did I pick a diamond out of my 27 picks from the deck? 9 times I picked a diamond. There's my probability. Remember, in this experiment, we're picking a card, we're looking at it, we're recording, did I get a heart, diamond, club, or spade? And then I'm putting that card right back in the deck. So I could pick it again. Example 4, we're doing in class. Oh, and I think that's it. There's the video questions. Please make sure you remember to do them in your notes. You don't have to copy down the entire problem, but I want to see that you actually went through the work of doing them in your notes.